Hello, my name is Joey Wateska, and I am a junior here at UNC. I am a biology major and a chemistry minor. Um, I am looking to be a ULA again this upcoming semester because I really enjoyed it this past semester. I want to continue helping kids in their studies and helping them better learn inside and out of the classroom when it comes to chemistry. I want to help them become more efficient whenever it comes to problem solving. And so if they're presented with a problem they wouldn't know, they could reason through it. And so, yeah, and I would also love to teach them some better learning strategies. Having been a ULA this past semester, I've already taken Education 150. So I've learned a lot of new learning strategies there. So I would educate them on some of them, like interleaving, space learning, and some other beneficial ones that have proven to be beneficial, and maybe clear up some old misconceptions that students have. All right, so next I'm going to go and work through an Orga 1 problem. All right. So this is a problem that I pulled from the Orgo 1 workbook, and it asks us to draw the curved arrow mechanism and show the products and include their stereochemistry. So the first thing I would do is look at the substrate and recognize that this is an alcohol reacted with HBr and heat. So the thing that comes to mind then is that this is an alcohol elimination reaction. So the first thing I always do is label the carbon that the oxygen is attached to as tertiary because it's attached to three other carbons, there, and there. And so then I also recognize that OH is a poor leaving group because it is a strong base. So to make it a good leaving group, we need to protonate it. So we draw the arrow from the nucleophile to the electrophile. So this lone pair on the oxygen will come and pick up this hydrogen, and Br minus will be formed as well. So that will make oxygen, hydrogen lone pairs. Okay, so now that we have our protonated oxygen, it is now a good leaving group. So, and also because this is a tertiary alcohol, it will likely react like an SN1 reaction, forming the carbocation because it is stable. So then this arrow, draw an arrow from here to here, showing the electrons moving to the oxygen, and we will form the carbocation product. And then here we don't include the dashes here because there is no stereochemistry there. We have eliminated it by getting rid of the oxygen. So now that we have, remember we have Br minus in solution from our first step of the mechanism right here. And so that is a good nucleophile. So it will attack the carbocation, which is a good electrophile. So we'll show the arrow from the nucleophile to the electrophile, attacking at the carbocation, and it will form two products. Um, the BR can attack from either side. So you can show the BR can attack from the front or the back. So it will form like that, or it can form this BR. So then you'll show both enantiomers of the products. And yeah, that is your solution with showing the stereochemistry. All right. Thank you so much for considering me to continue being a ULA, and thank you so much.